Hello everyone, I welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar, I am an assistant professor in IT department. Today we are going to talk about data structure, which is a course of semester 3 SYIT syllabus. Here we are going to discuss about linked list. So let's start with the topic. First, we will try to understand what is a linked list. I think all of you are aware of array. It's similar to array, but there is many differences. There are many differences. Array is different, linked list is different. Before I start the topic, I want to tell you about data structure. What is the data structure? So, whatever data we store in the computer, if we store in such a way that we can use it efficiently, then we can call it as data structuring. Here what data type, what data structure we are going to use is a linked list. So we can call a linked list is a data structure which can change during execution. So what is the basic difference between an array and linked list? Array is of fixed size and linked list can change during the execution. So if I define an array of 5 elements, it will remain fixed throughout the program. But for linked list, it is not needed to define. You can add the elements as needed. So suppose if I want a 10 element linked list, I can add. But afterwards, if I need 11th element, I can add, which is not possible in array. So linked list you can change during the execution. Then the other things are like this. Successive elements are connected by pointers. The two successive elements are connected by pointer. Last element points to null. So how the linked list is end? If it points to null, it is the end of the linked list. It can grow or shrink in size during execution of program. You can add elements as well as you can delete elements during the execution of program. It can be made just as long as required. It does not waste memory space. That is the main use of a linked list. It does not waste memory space, which is not possible in case of array. Keeping track of a linked list must know the pointer to the first element of the list called start head. So if you want to track the linked list, you should be aware of the starting. So that pointer we can call it a start or head. Linked list provides flexibility in allowing the items to rearrange efficiently, insert an element and delete an element. That is the main features of a linked list. You can insert an element during the execution of program as well as you can delete an element during the execution of program. So first we will try to understand that things. So this is the illustration for insertion. So you can see there is a linked list of 3 elements A. So A is connected with B and B is connected with C. So these are the 3 elements in my linked list. I want to add X inside this. So what I will do, I will create a temporary element X and then I will change the pointer of A. I want to add X in between A and B. So I will change the pointer of A to point to X. Okay. And then what I will do, my X pointer will point to B. This way I can able to add the elements in a linked list. So this X is item to be inserted and I can insert the item like this. So what I will do, I will change the pointer direction. So pointer of A will point to the new element and then the new element point to the second element. So this way I can able to insert a element in a linked list. So this is a code for insertion. It's a pseudocode. So if you see there is a linked list defined. So usually what is a linked list? So one data item is there and one pointer is there. So you can see that is defined on the top and I can call it as a node. Now when I want to insert a new element, what I will do, I will create a temporary pointer and then I can add that element in between my 2 elements which are already there in the linked list. So this is a pseudocode for insertion of the new element in a linked list. Now the second part is deletion. So how you are going to delete the element from the linked list. So if you see my linked list is A, B and C. These three elements are connected with the pointers. When I want to delete the element, what I will do, I will remove the pointer. I want to delete B. So what I will do, I will remove the pointer of B, and pointer of A will now start pointing to C. So the in between element get deleted. So after removing the pointer of B, I will make it as a temporary, and then I will change the pointer, and then I can able to delete the B element. So this way you can delete the element from a linked list. So this item B is to be deleted, and this is how we can delete the B element from the linked list. Now this is again a pseudocode for deletion. So on the top we have defined the structure that is for creating the node, and this is the function for deleting the node. So temporary we created, and then we change the pointer of the earlier and the next node of that linked list, and then we can free the temporary node, and you can see that your element is deleted, and your earlier element will start pointing to the next element, that is A is pointing to the C. Now what in short I can able to tell you, for insertion a record is created holding the new item. The next pointer of the new record is set to the link it to the item which is to be follow it in the list, and the next pointer of the item which is to the precede, it must be modified to point to the new item. So how we are doing, we are creating a temporary new item, then our next pointer of prior means next element of the new item, it will start pointing to the next element in the new item, and the preceding pointer of the element will start pointing to the new item. This way you can insert a new element. Now for deletion, the next pointer of the item immediately preceding the one to be deleted is altered and made to point to the item following the deleted item. So first the next pointer of the item immediately preceding to the item which you need to delete is altered, and after deleting the item which we want to delete, then it will start pointing to the next item which is there after the deleted item. So this way you can insert an element in the linked list as well as you can delete the element from the linked list. After telling you all this concept, I am coming to the concept which I started initially, that what is the difference between array and the linked list. Array are suitable for inserting and deleting an element at the end. You can insert and delete elements only at the end. Randomly accessing any element, you can randomly access any element in the array. Searching the list for a particular value, you can easily search a particular value in your stored list. Now linked lists are suitable for inserting an element, deleting an element at any position, applications where sequential access is required, and in situation where the number of elements cannot be pre-detected beforehand. Like suppose I want to store the number of students in different classes. In some class there are 5 students, in some class there are 10 students, in some class there are 80 students. Now if I define an array for this, so maximum is 80, so I have to define the array of 80 elements. But when I stored the names, so in one class there are 5, so the remaining almost 75 places will remain vacant. So that is the vestige of memory. We can imagine if there are more classes that way. But with linked list, if I want 5 elements, then I can create a linked list of only 5 elements. If I need 80 elements, then I can create a linked list of only 80 elements. So this way it is more in saving the memory, as well as inserting and deleting elements at any position is possible with linked list, which is not possible with array. In array, you can add the element at the beginning or at the end. In between, it's not possible. Now, types of list. Now, we have seen linked list. So, there are different type of list. They are as follows. Depending on the way in which the linked lists are used to maintain adjacency, several different types of linked lists are possible. This is linear singly linked list, which is shown in the image is linear singly linked list or simply linear list. Okay, so here my starting element is the head, which is connected with B with a pointer and which is connected with C with a pointer, and pointer of the C element is pointing to null. That means this is the end of the linked list. Now this is a circular linked list. The pointer form the last element in the list point back to the first element in the list. Here there is no end. The pointer of the last element is pointing to the first element. This is called as circular linked list. Now then there is a doubly linked list. Doubly linked list means pointer exists between adjacent node in both directions. So if you see, pointer from A to B is also there, from element A, first element to the second element, as well as from second element to the first element. So in both the direction it exists. The list can be traversed either forward or backward. So that way you can traverse in the link either forward or backward. Usually two pointers are maintained to keep track of the first, head and tail. So this way you can keep a track of head and tail. Okay, now basic. Okay, now when you want to learn the linked list, so you should know how to define the linked list, then how you can able to add the elements in the linked list, and how you can able to delete the elements from the linked list. Now some basic operations which we can perform on the linked list are creating a list. That what you should know how to define a linked list in different programming languages. Then traversing the list. Traversing the list means you need to find out the data from wherever you stored it. So linked list also you are using for storing the data. So you have to easily traverse to the linked list. Suppose if you want an element from the second position, or if you want an element from the fifth position, you can easily find it out. Inserting an element in the linked list and deleting an element from the linked list. So this four basic operations you should be aware when you are using a linked list. See, this is not only for any specific programming language. You should know about in different programming language like C, Java or Android. There are different languages. In all the languages you should know how to create the linked list and how to perform these basic operations on the linked list. Connecting two lists into one. This is also one more basic functions. List is an abstract data type. What is mean by abstract data type? It is a data type defined by the user, typically more complex than simple data types like integer, float, etc. So this is not a predefined data type like integer or float. Like these are the predefined data types. These data types you create, you define. So that's why it is called as a abstract data type. And typically these data types are little more complex. Why abstract? Because details of the implementation are hidden. When you do some operation on the list, say insert an element, you just call a function. Details of how the list is implemented or how the insert function is written is no longer required. See here, whatever we are doing now, we are defining the different functions. So for creating a node, we need a one function. For inserting a node, we need a one function, and for deleting the nodes, we need a function. So whenever you need to perform any operation, you need to call the function, and then the operations will be performed. Details of how the list is implemented or how when you want to do some operation on the list. For example, suppose if you want to insert the element, that time the details, means the function to create the linked list or the function to insert function is no longer required. So that's the reason we need some abstract data for defining the linked list. This is a conceptual idea, list implementation and related functions. So the main basic three functions: insert, delete and transfers. That's all for today. Thank you.